Professor Bob Young here. In this instructional video, we always like to show you where you use math in real life, especially with linear equations and one variable and so forth. So we're going to just do a short video here on modeling data, which you may get in statistics or business type classes. All right, so we've got a chart here, finding the equation of a line that models data. So notice on this chart, you see a lot of these things in the newspapers and business magazines and weeklies and stuff. And they've got X labeled the years, and notice they're starting with the year 1996, and they've got Y is the cost in dollars here, and it's 3,151. So X and Y don't always have to be like between 1 and 10 and things like that. And notice in 1998, X is 2, so they've kind of got this thing, and I'll go ahead and add a little here. 1996, 1998, 2000, 2002, 2004, 2006. So that's what I'm looking at here. It looks like increments here. And then they've got the cost in dollars here plotted, and it almost looks like a linear pattern, doesn't it? That's pretty close to a line. So we're just analyzing some data here. Now it says find an equation of the line. So here's something you could actually use this in real life. Oh my gosh, Young, that models this data. So notice it says the points lie in approximately a straight line here, and we want to write an equation that models the relationship between year X and cost Y. So what we're going to do is just pick a few points, and we can pick any two here on this data here. So we're going to choose the point 0, 31, 51. Okay, so it looks like this would be a good one to pick because I think that could be called something, maybe the y-intercept. And one other point here, and I guess to get a good measure here all the way across from one spectrum to the other, we'll take the point 10 and 5,836. All right, now of course if we're going to write the equation of the line, we're going to have to do the slope. So we went ahead and just like we've always done, we took y2 minus y1 over x2 minus x1. And we've got our slope number is about 268.5. Now it says the slope, 268.5, indicates the cost of tuition and fees increased by about $269 a year. So really I think they're talking about this model here being like cost of tuition over a certain amount of time here. So they're giving us a little more as we go along. It says use the slope and y-intercept of 3151 to write the equation of the line. So if we know the slope and y-intercept, y equals mx plus b, plug it in, and we're going to get y equals 268.5x plus 3151. Now it goes on for the next one here. It says use the equation developed to predict the cost of tuition and fees at a public four-year college in 2008. So notice here it says the value of x equals 12 corresponds to the year 2008. All right, so we substitute 12 in for x. So that's going past our chart now. So we can, if this model holds, this linear model, we can keep using it to go even farther out number of years. And now we're just putting in 12 for x and solving, and we get y would be 6373, the cost. So if it keeps moving along like this, which may not be far off, those of you in college knowing this, see how this is kind of going. It still seems to be, if we were going to plot things up here, would be lining up a little bit. All right, and it says use the equation developed here. So we went ahead and said that already, that it would be 6373. So in review, let's say your guidelines for fitting a curve, make a scatter diagram of the data. And a lot of times, over the years, they'll have these somewhere. And then find an equation that models the data. Now for a line, this involves selecting two data points and finding the equation of the line through them. So again, yes, we try to emphasize that you'll use this math not just for being tortured by me and other fellow math faculty, but business and all kinds of applications that you may use outside our doors of BCC. Bob Young signing off.